Welcome back to Math 103. This is video number 14 on growth and finance. Continuing with our example of a bank account with an APR of 4.5%, but now with weekly compounding, we can ask, what is the weekly growth factor? There are 52 weeks in a year. It's true that it's not exactly 52 weeks, it's 52 weeks and a day, or 52 weeks and 2 days in a leap year, but the convention in financial settings is just to think of a year as consisting of exactly 52 weeks. So over the course of those 52 weeks, the bank is multiplying your account balance every week by the weekly growth factor. It's taking the year's worth of interest and dividing by 52 to find out a week's worth of interest. We really need to carry a large number of decimal places here to maintain accuracy. So the weekly growth factor will be approximately 1.000865385. Right? Why do we divide by 52? Because we are finding out a week's worth of interest. Once we know the weekly growth factor, we can figure out the effect of a full year of weekly compounding. So over the course of a full year, the bank multiplies your account balance by the weekly growth factor 52 separate times, with the result that That $3,000 that you start with grows a tiny bit, but 52 separate times, and grows into $3,138.02. That net amount at the end of a year of weekly compounding is slightly greater than what you have at the end of a year of monthly compounding. Again, the more frequent compounding produces a slightly more advantageous result at the end of a full year. We can pull all this together by taking a fresh look at the compound interest formula. Future value equals present value times 1 plus interest rate as a decimal, raised to the nth power, where n is the number of times that interest is compounded. Right, so as before, this formula does nothing more than summarize our reasoning process of starting out with some amount of money, PV, multiplying by a growth factor every so often, whether that's every year or every month or every week, and however many times we applied that small growth factor, that's the power that we're raising 1 plus I to. What's new here is our more refined understanding of what I can really stand for and what n can really stand for. So I is the interest rate per compounding period as a decimal. Right? You're given an APR, so that tells you 1 year's worth of interest, 1 whole year's worth of interest, but we may need to adjust that to a monthly interest rate as a decimal, a weekly interest rate as a decimal. However frequently we're doing the compounding, whether it's yearly, monthly, weekly, daily, hourly, 1 plus I stands for the growth factor for each individual act of compounding. 1 plus I to the n is therefore just the overall growth factor for the full amount of time you're considering. However many separate acts of compounding there are, that's n. What we now appreciate is that this n, this number of times compounding occurs, might be counting a number of months, a number of quarters, a number of days, a number of half years, etc., whereas before we were just counting a number of years. Our formula turns out then to be quite versatile and to be able to handle many real-life situations.